Now part D for the students, AA students, and I guess it will be part E for the AI students. It's about the least square regression line. It's again the same line as we discussed in the previous part, the line of the best fit, which was subjective. Remember when we had our points on a scatter diagram, we try to draw a line which the line of the best fit by the eye. So what we did, we just need the mean of these points, and we said that it should pass. Okay, let me put the mean first. Let's say the line is this one. Again, it's changed from person to person. If I draw this line, approximately, it should be something like this. But again, as we said, it's subjective. We should calculate it. Actually, it's calculated. I will try to quickly explain what the idea is. All these points have their coordinates as x1 and y1. And this one, let it be x2, y2, x3, and y3. I'm just trying to explain the idea behind how they managed to find the formula of the line of best fit by calculations. What they try to do, this one are the actual points, and this one the line of best prediction. So as you can see, according to my prediction, for the x1 the value must be this one on the line. For the x2 the value must be on the line. For the x3 again the same on the line. They must be on the line. So to find the perfect, the best, the best line, what they did, they tried to minimize this distance. The idea, you don't need to know it, you just need to know the formula, but the proof, I'm not going to prove nothing here. This distance, they try to minimize it. And by that minimizing, as it's a line, it will have this equation, correct? Or it can be also written like this. Doesn't matter. In some places, you will see that there is a head. They also put this notation. In some books, they use them. But after all, it's the same thing. You have a gradient and you have the y-intercept. So with a better picture from your book, here we have it. We try to minimize this, and there is a formula for them to calculate it. We said they try to minimize this distance. They went from the optimization. And just know the idea. We'll try to solve by using calculator. For example, let's go one by one from your book. One question. There is a group of children who ask about the numbers of hours they spend exercising and watching television. So what do? We need to draw a scatter diagram, calculate R, the correlation, Pearson correlation coefficient. So what we need to do, we need to draw a scatter diagram. We can do it by hand, but also we can see it in calculator. We know how to do it. Yes, for example, here we need to put time for exercise, and while it be time for television. Okay, so it's if it's 1 hour, it will be 24. So you just put the point. Let me show with calculator. Let's do it with calculator. Now if I input the numbers for the first one, 4, 1, 7, and for the second column, 12. Now here I have my data, and what do? We need to graph it, scatter diagram. Here we see it. Now what you can say here from the picture, there is a negative linear correlation, yes, and whether it's a strong, moderate, or weak, we need to find that R. We need to go X, and we see that the R is, what's it, minus 0. R equals to the Pearson correlation coefficient is minus 0.927. And also for the AA students, just extra information, you don't need to know it. This one, R squared, actually this information, let me write it also. It was 0.85, I guess. 0.859. It tells you about how well your line is well fit for your data. How well. If there is a question like how well, it's set by 85.9%. So it's pretty well number. So these R square, you don't need to know it, but if you're doing for your IA, this number is very important. Okay, so there is a strong negative correlation between the hour spent by exercise and television spend time. So here we did it. We drew the scatter diagram with calculate, describe the correlation between the time. So we described it. What we said, it's a negative, strong correlation. I will be short. Find the equation of the regulation line and draw the line on your scatter diagram. So what's that line is? From calculate, look at here. What do we have? Here you have a line equation, ax plus b. And above you see the numbers. A is the coefficient of x minus 2.12 and the b is 22.09. So this one is actually the formula for your line. Formula for your line. And it's part D. What's it? Y approximately equals to minus 2.13x plus 22.1. So it was A and it was B, if I wrote them correctly. Yeah. So what do they mean? In part E, state and make interpretation, the gradient and the y-intercept of the gradient. So what's the gradient is? We know from the definition from the line what was the gradient. By each additional hour that students spend on exercises, the number of hours they spend watching TV each week decreases as because it's a negative, right? Increase in independent will cause decrease in dependent. So which straightforward. 1 hour you study, it will decrease 2.13 hours of the spending time of watching television. So exercising is good for health, something like this. And what's this y-intercept means? If you don't exercise at all, you'll be spending 22.1 hours on watching TV. So this one is interpretation for the y-intercept. Now, one of the children in the group exercised for 7 hours. So here I really need the graph. How much television does the child of the book, the graph, because we did draw it on calculator. You can just copy paste on your paper when you draw by calculator. Now, what I say, one of the children in the group exercised for 7 hours. Where is 7 hours here? It's here. How much television does the child watch weekly? So we go and check it. What is it? Sorry for that. When he studied 7 hours, how much television? From our prediction, our line, it's about approximately 7, correct? But from our actual data, here the point is, the student studied 9 hours, correct? And from the prediction, it's 7, approximately 7 point something. Can't be sure here. What we can do, we can plug in a calculator. Here I have the line, I can get the exact result. Y equals the example minus 2.13 multiplied by 7 plus 22.1. So instead of x, we put 7, and the result is approximately 7.22 hours. So it's 7.22. So how we approximated from the line. That's why we need the line. So compare your answers in 1 and 2. So what does it mean? My prediction is kind of low. So the child actually watched more hours than I predicted. So kind of error here. So here's the interpretation. I compared my result from my prediction and what it actually is.